welcome to our second online study session. This is for MAT1033C, and this will be a review for test 2. Let's go to question number 1. This first question says, determine whether the ordered pair is a solution of the system of linear equations. So basically, two linear equations in the coordinate system. There are three options or three types of things that could happen. Those two lines in the coordinate system, they could either cross and you will have a certain point. They could be parallel, which means you will have no solution because they're never ever going to cross. And the third option that you could have is that the two lines are exactly on top of each other. So one line is basically the same as the other line. And if you are given a point to find out if it is a solution by just plugging in that point into first one and then the other equation and see if you get a true statement. So when you have a point, this will be your x value and this your y value. And we take in the first equation, which is x plus y equals 1. And we are just going to plug in these coordinates. So starting with -5 and then plus, for y we have -4, which is equal to 1. All right, so I can combine these two signs. So -5, a positive times a negative is a negative, equal to 1. And now -5 minus 4 is -9, which is not equal to 1. So right here, I could stop. I don't even have to plug in this point into the second equation, because whenever I have a statement that is not true, which means this is not a solution, so no. All right, so number 2 says solve the system of equations by using the elimination method. This system is already perfectly set up where you have your x values, your y values, and then your constants on the other side of the equal sign. So the best method for this system is the elimination method, but what we have to do is we need to cancel out either one of the variables, and it doesn't matter which one. So looking at this system, I would probably choose to cancel out the x values just because they like smaller numbers, but it doesn't matter. You should still get the same answer even if you would start with your y value. But starting with x, so I need to find a number. I have to multiply the first equation and the second equation. It is a different number to cancel each other out. So it's like kind of finding the least common multiple. And for -3 and 5, the least common multiple is probably 15. So I will multiply the first equation by 5 and the second equation by 3. And then I will get for the x value in the first equation -15 and for the second one +15, and that would accomplish my goal of canceling out the x value. So let's start now to distribute the 5 to everything inside my parentheses. So I'm just rewriting the first equation. 5 times -3x is -15x, and then 5 times +7y is +35y, and 5 times 24 is 120. And now let's also multiply through the second equation by 3, and we get 3 times +5x, so that is +15x. And then 3 times -4y, which is -12y. And then we have 3 times -17, that will be -51. So with the elimination method, we basically just adding down. So another name for elimination method that you might hear a lot is called addition, the addition method, but it's basically the same method because actually you're just adding down. Adding these two will cancel out, would just give me a 0. And then we have 35 minus 12y, which gives me 23y. And then we also have 120 minus 51, which is 69. Now the last step to get y by itself, we would have to divide by 23 on both sides. 69 divided by 23, 3. So we found our first value, which is y. And now we are going back and choosing either one of the original equations, and I'm going to pick the second one, but there's no right or wrong, so you could have also picked the first one. And I'm going to plug in my y value to get my corresponding x value. So 5x minus 4, now y is 3 times 3 is equal to -17. So 5x negative 12 equals negative 17, adding 12 to both sides, and that leaves me with 5x is equal to negative 5. Okay, now divide by 5 on both sides, so x equals negative 1. And remember, like I said in the previous slide, that these systems of equations are either crossing somewhere parallel lines or the exact same line. In this case, we have a point, so those two lines are crossing and we have to write it as a point. So negative 1, 3 would be the point that the two lines are crossing. Then we move on to question number 3. They want us to use the substitution method. So usually the substitution method you use when you have one of the variables all by itself. In this case, we have x all by itself. So what we do is we take the value, what is x, and plug it into the second equation for x. So basically we're substituting. So 5 times, now x equals 9y plus 7. And then continuing with the second equation, minus 45y is equal to 3. All right, using distributive property to get rid of the parentheses, 5 times 9 is 45y, and 5 times 7 is positive 35. Minus 45y is equal to 3. So right here, combining like terms, and 45y minus 45 cancels out or equals to 0. So I'm left with 35 equals 3. This is not true, so it's not equal to 3, and that means that this system would represent two parallel lines. So the actual solution to this would be no solution, because there's no point that those two equations ever cross, so no solution. Question number 4. We are supposed to translate the system of equation, but we are not supposed to solve it. So it says one number is 2 less than the second number, and twice the second number is 2 less than 3 times the first. Write two equations to represent the system using x for one number and y for the second number. Okay, so again, just starting with the first sentence, let's see what information we have. We have one number and one number is represented by x. So starting with x is usually translated as the equal sign, and then 2 less, so 2 less usually goes in the back, because 2 less than what? So 2 less than a second number, which is indicated by y. So 2 less than the second number, y minus 2. Then the next sentence says twice the second number. So the second number is y, and twice means 2 times. 2 times y is equivalent to the equal sign. 2 less, again, I put that at the end, the same as if you get 2 more, you should also put that at the end. And then 2 less than what? Then 3 times the first. So 3 times x. So we translated those two equations, and we are not supposed to solve it. So I'm moving on to number 5. Dividing using long division. Okay, so first of all, if you have a long division problem, you should rewrite it to set it up nicely, starting with the second number or the second part. So writing negative 3x minus 1 first, and then under my root, I'm putting the first part, so 9x cubed plus 15x squared, and then plus 16x and plus 9. So with the long division problems, you basically have two things that you need to watch out for, which is the terms need to be in descending order, looking at the highest term, which is the one that has the highest exponent, so 3, then they're supposed to go down, descending. So 3, 2, 1, and this is basically 0. It has 0 axis here. So this is set up in descending order, and here the highest one would be 1, and then 0 or none. So this problem is already set up in descending order. And then the second thing that you have to watch out for is that every term is present. So if it starts here with 3, then it needs to go down to 1 and 0. So every term is present. And if this one starts with 1, then the next one is supposed to be 0. This also got all the terms. So having it set up, we're going to start by asking ourselves, how many times does the negative 3x go into 9x cubed? Or by what number do I have to multiply the negative 3x to get 9x cubed? I would have to multiply it by a negative 3 to get the 9, and then x squared to get x cubed. So testing it, basically distributing it back in, negative 3x squared minus 3x gives me 9x cubed. This first term always have to be the same. So it is, which means we found the right number, and now also distributing it to the second number. So negative 3x squared minus 1 is positive 3x squared. Now the next step is I would have to subtract like with a regular long division problem, and that would change my signs if I distribute the signs. So the 9x cubed become now negative, and the 3x squared also becomes negative, because a negative times a positive is a negative. Adding down, this cancels out, and 15x squared minus 3x squared is 12x squared. Bringing down the next term, so plus 16x, and then starting over again. By what number do I have to multiply negative 3x to get to 12x squared? I have to multiply by negative 4 to get to 12, and I already have an x, so I need one more. So negative 4x, distributing it both terms. So negative 4x times negative 3x gives me 12x squared. And negative 4x times negative 1 gives me positive 4x. Again, subtracting, which changes all the signs. This becomes negative, this also becomes negative. And now adding down, 12x squared minus 12x squared cancels out as 0. And then 16x minus 4x is 12x. Bringing down the last term, so plus 9. And again, how many times does the negative 3x go into 12x? I would have to multiply by negative 4. Negative 4 times the two terms, so negative 4 times negative 3x, positive 12x, and then negative 4 times negative 1 is a positive 4. Subtracting, changing the signs, and adding down cancels out, and 9 minus 4 is 5. Okay, I don't have any more terms here, so I'm done, and I do have a remainder. Now I have to put everything together. This would be my answer, my quotient, and this is negative 3x squared minus 4x minus 4, and then my remainder, I add that, and the remainder wasn't able to be divided, so that just goes in the bottom. The actual complete solution to this problem would be written like this.
So let's keep going. Number 6, divide using long division. So we're going to just pick up where we left off. So the dividend is the 8u to the 4th plus 12u cubed minus 2u. And the divisor is 2u squared plus u. Now, we want to make sure, and I just noticed this, when we divide using long division, like we just mentioned, you want to make sure that your exponents are in decreasing order, and you want to have representation of all of the terms. So if you notice, we actually are missing a u squared term here. So insert a u squared term. So we've got u to the 4th, u cubed. So we're going to say plus 0 u squared, and then we can write our minus 2u. Okay, so now we're ready to go. So we're going to take the leading term in the dividend divided by the leading term in the divisor, or 2u squared times what gives you 8u to the 4th. So that's going to be 4u squared. So now we're going to multiply 4u squared times both terms in the divisor. So 4u squared times 2u squared is 8u to the 4th, which is our goal. We want to get the same term. And then 4u squared times u is 4u cubed. And so now we want to subtract. So 8u to the 4th minus 8u to the 4th cancels out. 12u cubed minus 4u cubed is 8u cubed. and then we're going to bring down the plus 0u squared. And now we're going to divide again. 8u to the third divided by 2u squared would be positive 4u, because 4u times 2u squared is 8u to the third, and then 4u times u is going to be 4u squared. And this is why it was so important to have that 0u squared so you can follow the pattern easily. Now we're going to subtract here. The 8u to the third cancels out, and then 0u squared minus 4u squared is negative 4u squared. And now we're going to bring down minus 2u, and then we're going to divide again. So negative 4u squared divided by 2u squared would give you just negative 2, because negative 2 times 2u squared is negative 4u squared. We always want to get the same term here. And then negative 2 times u is negative 2u. And then we're going to subtract, and then both of these cancel out, so your remainder is 0. So your final answer is just 4u squared plus 4u minus 2. That is your quotient with no remainder. Okay, number 7, we're going to factor. You always check for a greatest common factor when you are factoring a polynomial, which in this case we do not have a greatest common factor. So next we're going to look at how many terms we have. So we have 2 terms. So we have 2 options after deciding if we have a GCF to see if we can factor. Do we have squares, perfect squares, or perfect cubes? So in this case we have perfect cubes. So 25c to the third is a perfect cube, and then 64 is a perfect cube. So this looks like a cubed plus b cubed. And we factor that like this: a plus b times a squared minus ab plus b squared. So we need to identify what the a is and the b is. So 125 is 5 to the third, and then c to the third will give us 5c as our base to the third power. Take the cube root of 125, and that'll give you the 5 that you need. Then take the cube root of 64, that's 4, so that's 4 cubed. So now I can see that my a in this case would be the 5c, and the b would be the 4. So let's start factoring it out. So a plus b in this case would be 5c plus 4, then times a squared, which in this case would be 5c squared, minus a, which is 5c, times b, which is 4, plus b squared, which in this case would be 4 squared. Now let's clean this up. So we have 5c plus 4 times 5c squared, 25c squared, minus 5c times 4 would be negative 20c, and then 4 squared is 16. And so now we factored this sum of cubes. So we have sum and difference of cubes. This is a sum because we're adding here. Okay, so number 8. Let's see. So we're going to use the graphing calculator to graph this system of equations, and we're going to determine the solution. So in order to use the graphing calculator, we want to make sure that it's in slope-intercept form, which in this case it is, because the calculator is set up to put equations already set equal to y. So we're good to go here. So let's look at our graphing calculator. To graph this system, you want to go to y equals, and you want to make sure there's no equations in there, and we're going to put the 2 equations here. You want to use this negative symbol for negative 2x minus 3, and then we'll just cursor down to the next one. So that's negative, and I'm going to put my 3 over 2 in parentheses, negative 3 over 2, close parentheses, x minus 2. Okay. So we're going to graph this system. So if your graphing calculator is already in the standard basic format, your window will probably be fine. If you've done something else on the calculator and your window is moved around, a good quick way to make your window have a standard frame, if you press zoom and then choose standard, go down to number 6, so you can just press 6 and then press enter, and that'll give you a quick way to focus your graph on the basic negative 10 to 10 x and y axes. So it's intersecting, but that's kind of hard to see. But the great thing about the calculator, it will find the intersection for you. So the way to do that, you're going to go to second and then calc. So you're going to press the trace button to get that calc function. and you can calculate a few things. So we want to find the intersection, so we want to choose option 5. Okay, so all this is doing here is trying to define what two curves or line we want to use to determine the intersection. It says curve because you can actually graph all types of equations, but we're just graphing lines. So I'm going to press enter because it's flashing on this line. So that's just saying, okay, I want this to be my first line, and then now it's flashing on the second line. So just press enter twice, and now it's saying, do you want me to guess? And I want to say, yes, I do. So you press enter, and so it tells you exactly the intersection point. So the intersection point is -2, 1. So you would write that as an ordered pair. And then just as a tidbit, if you were given a point and you were asked to see whether it was a solution, then you would plug in the point into each equation to make sure it's a true statement. But by graphing them on the graphing calculator, we can see that is a solution of the system because it's the intersection. So number 9 says to graph the linear inequality using a graphing calculator. So here's our inequality here. 2x minus y is less than or equal to -8. So like I said before, you want to put it in slope-intercept form if you're going to use the graphing calculator. So we want to set it where y is by itself. So let's start by subtracting 2x. So -y is less than or equal to -2x minus 8. But we want positive y. So let's divide everything by -1. So that's going to give me y. Now it's an inequality and I'm dividing by a negative. That's going to flip my inequality sign. Y is greater than or equal to positive 2x plus 8. So this is what we're going to put in the graphing calculator. So you want to put in slope-intercept form first, and now we're going to go back to y equals, and I want to clear these equations out because I'm graphing something different. So I'm going to put 2x plus 8. Now right now it's y equals 2x plus 8, but I want to graph an inequality. So we're going to cursor to the left where you see those lines to the very left, and it's flashing now. We can press enter to get several different options. We can get a thick line, we can shade above, we can shade below. These are all options here. So this says y is greater than or equal to 2x plus 8. So we want to shade above. So we're going to press enter until we can see the shaded above option. So you see how it's showing that upper corner shaded? That's the one we want to use. So that is the way of telling the calculator, I want to graph y is greater than or equal to, or just greater than, because it doesn't specify whether it's a dotted or solid line when you're shading. So now we're ready to graph. We press graph, and then there we go. So that's our graph of the inequality. And then if we go back to our options, that would be option A, okay? So the more familiar you are with your graphing calculator, the easier some of these questions can be for you. All right, so now we're going to graph a system of linear inequalities. So again, we want to make sure they're both in slope-intercept form. So this first one, if we subtract 3x on both sides, that will give us y is less than -3x plus 3. So that's ready to go. And then we'll do this one. Again, we subtract 3x on both sides, so we'll have y is greater than -3x minus 1. Let's go to the graphing calculator, and again, we want to go to y equals. Let's clear this out, and let's put our new system of inequalities. So we have y is less than -3x plus 3. So I'm going to set that up to where it's less than. So I want to choose the bottom corner. There we go. And then now for the next one, it's y is greater than, so let me go ahead and set that inequality up, -3x minus 1. Okay, so those are our inequalities, and now we're going to graph it. Okay, so remember for a system, when we're graphing, we're looking for the intersection. So number 8, it was a system of linear equations. So the intersection was 1 point. This is a system of linear inequalities, so the intersection is actually a region of points. So if you notice, this is my shaded region that's overlapping in between those two parallel lines. This is where our intersection is. This is the solution. So even though the screen, the whole thing is shaded, we only care about where they overlap. So if we go back to our options, that would be option A. okay, because that's where the two were overlapping, okay? If you notice, this is less than and just greater than. So it's not less than or equal to, or greater than or equal to. So when it's less than or just greater than, you're going to use a dotted line. So if you notice, even though the graphing calculator doesn't really show that well, then you know that that's why these two lines are dotted, because they were not or equal to. Now if it was less than or equal to, or greater than or equal to, you would use a solid line. Because you could have a question where option A looks like this, and let's say option B almost looks exactly the same, but they have solid lines. So you would need to know the difference between the two. So this one, all of them are dotted, but you want to be aware of that as a possibility, because that could be two different answer choices, and you need to know why they're using dotted versus solid, or vice versa.
So number 11, solve the application using a system of linear equations. Let's read it first. It says a theater sells two types of tickets to their plays, children's tickets and adult tickets. For today's performance, they have sold a total of 1,165 tickets. Also, they have sold 4 times as many adult tickets as children's tickets. So how many children's and how many adult tickets have they sold? All right, so knowing that we are dealing with systems of linear equations, we're going to have to come up with two equations. Look at the first sentence and read it again, and you should be able to come up with an equation. It says that they have two types of tickets, children's and adults, and then in the second sentence it says that these two types of tickets total to 1,165. Which means if we take the children's tickets, and I'm calling in C rather than X or Y, so I know which one are which one. So the children tickets plus the adult tickets would total 1,165. I got my first equation. Now the second equation I would get from this sentence. So they have sold 4 times as many adult tickets as children's tickets. So the adult tickets is 4 times the children's tickets. That's my second equation. So now I have a system, and I can use either the elimination method or the substitution method to solve for A and C. In this case, I'm choosing the substitution because right here the system is already solved for A, so I can use this and substitute that in for A into the first equation. So C plus, and now for A I'm going to plug in 4C, is equal to 1,165. Okay, solving for C, so 1C plus 4C gives me 5C, and that's equal to 1,165, and then dividing by 5, and C equals, you can use a calculator or you can do the old school way of long division. So 5 goes into 11 2 times, which is 10. Subtract 1 left, bring down the next one. 16 goes in 3 times 5 is 15. Subtract 1 left, next one down is 15, and 5 goes into 15 3 times. So my children's tickets were 233. I found my C, now I should be able to find my A. I'm going to use the first equation, or I can even use the second equation because it's already solved for A. So my adult tickets is equal to 4 times my children tickets, and A is equal to 932. Okay, so we have our A and we have our C. So children's tickets 233, adult tickets 932. So number 12 says, first of all, solve this application using a system of linear equations. So let's write two equations. The first one would be one number is 6 less than a second number. So one number, let's call that number X, which is equivalent to an equal sign, and then 6 less than what? A second number, which I call Y. So my first equation is X equals to Y minus 6. And then my second equation, so I have twice the second number, which would be 2 times y, is, so equal sign, and then 9 less than 5 times the first, 9 less 5 times the first, which is x. So I have my two equations, Again, the system is set up for me to use the substitution method because x is isolated, so I can just use that to plug this into x for the second equation. 2y equals 5 times, now my x is y minus 6, and then minus 9. Distributing, so 2y is equal to 5y minus 30 and minus 9. Now combining like terms, so I have 2y is equal to 5y and then minus 39. Subtracting 5y from both sides to get y all alone cancels out. On this side I now have negative 3y is equal to negative 39, and then dividing by negative 3, which is positive 13, because negative divided by a negative is a positive 13. Okay, so we found the second number. Now we have to go back and use either one of the two original equations, and in this case I am using the first one because it just looks simpler, less work, and I'm plugging in 13 for y. So x equals 13 minus 6, so x is equal to 7. So when you're plugging it into your test, make sure that the first number, which is indicated by x, would be 7, and then your second number would be 13. Let's move on. Another word problem. And this says solve the application using a system of linear equations, and Marcus earned $8,100 during his summer vacation. He invested part of that money at 10% and the rest at 6%. So if he received a total of $610 in interest at the end of a year, how much was invested at each rate? First of all, whenever we are talking about a percentage problem, we need to know a little formula. You have I, which is equal to P, R, and T, where I stands for interest, P stands for principal, R is the rate, and T is time. And that formula would help you to solve the system. And usually for this type of problems, I like to set up a table, and I'm going to have two different accounts, one that is at 10% and the other one at 6. So this is my first account and my second account, and then in the bottom would be my total. And then I can use this, so P, R, and T, which is equal to I. And now I'm just going to go ahead and plug in all the information that I have been given in the word problem. So the $8,100 represent the principal, because this is what he made during his summer vacation. And that's the total principal, so that goes down here. Now I have two different rates. So my first account, I'm going to choose the 10%, and my second account is 6%. Then the time, it says it's 1 year. So 1 and 1. And now the last amount I have is 610, which is the total interest I received. So that goes right here. So I filled in all the information that I've been given, and now I'm going to have to choose my variables. So for my first account, I'm going to choose X, and for my second account, I'm going to choose Y. Now going to the right, remember I equals PRT, so I'm just going to multiply these three items together. And remember, whenever you're dealing with a rate, you also have to convert it into a decimal. So 10% becomes 0.1. You move the decimal place 2 places to the left. So multiplying these together, I get 0.1x times 1 is still 0.1x. And then for the second line, I'm multiplying these together, again converting this into a decimal. So y times 0.06 times 1 gives me 0.06y. Okay, as you see now, if I'm looking at this and I'm looking at this, which are totally filled out, so I have two equations, because if I take the first account principal and I add the second account principal, I will get my total, one equation. So x plus y equals 8,100. And then my second equation, to get my total interest, I take the first account interest, add the second account interest, and I have my total interest. So 0.1x plus 0.06y is equal to 610. Okay, so I have my two equations. Now I need to decide on either choosing the elimination method or the substitution method. I prefer the substitution method, so I'm going to solve this first equation for x. So moving y over to the other side, and I would get x is equal to 8,100 minus y. And now I take this equation and I'm going to substitute it into the second equation for x. So 0.1 times 8,100 minus y, and then plus 0.06y is equal to 610. Using distributive property, I'm going to distribute my 0.1. I will get 810, and then 0.1 times negative y, so I get negative 0.1 y plus 0.06 y, which is equal to 610. Combining like terms right here gives me a negative 0.04. So I still have my 810. Then combining these two together gave me 0.04 y, and that is equal to 610. We're solving for y, so subtract 810 from both sides, and we are left with negative 0.04 y, which is equal to negative 200. All right, last step, dividing by negative 0.04 y on both sides. So y is equal to 5,000. Okay, I found my y value. Now I need to go back to one of my original equations, and I'm going to pick the first one because it's just easier to find my x value. Using the first equation, which was x plus y equals 8,100, and plugging in my y value, I should get my x. So x plus 5,000 is equal to 8,100. Subtracting 5,000 from both sides, our x is equal to 3,100. Okay, referring to the problem now, this means that my first account, which was at 10%, so that was x, the principal that Marcus put in that account was 3,100, and then in the second account, which was at a rate of 6%, the amount he put in that account was 5,000. So now going back to systems of linear equations, this question asks us if this system has one solution, no solution, or an infinite number of solutions. There could be three different solution types. So you could have one solution if the system or the two lines are crossing. You could have no solutions if you have two parallel lines. Or you could have an infinite number of solutions if one line is exactly the same as the other line. To find out which one it is, we would have to use either one of the methods to solve the system. And looking at it, I'm probably in this case going to use the addition method. I'm going to leave the first equation as is, and I am going to move the 16x over to the other side by subtracting it from both sides. So now I have 4y minus 16x, which is equal to 8. So I lined up my variables perfectly. Now I can use the elimination method, or also called addition method, to be able to cancel out one of the variables. I am going to multiply this first equation by negative 4. That will give me negative 4y, which would cancel out with the positive 4y. So just distributing the 4 to everything inside, I get negative 4y plus 16x, which is equal to negative 8. So now I can just add down these two equations. 4y minus 4y, which cancels out, is 0. Negative 16x plus 16x also cancels out, which is 0. And then 8 minus 8 is also 0. So now I have 0 equals 0. This is a true statement, and whenever I have a true statement, that would be lines that are exactly on top of each other. So this version, and that means there is an infinite number of solutions because every single solution from one equation is also a solution from the second equation. Whenever you get a true statement, it's infinitely many solutions. If you get a point, it's one solution, which looks like, for example, -2 and 3. And parallel lines, you will get a solution that is not true, something like 3 is equal to 5, which is not true. So these are the three versions, but for this particular problem, the solution was infinitely many. Question 15. Solve the system of linear equations by clearing the fractions. So for us to be able to clear the fractions, if you have one fraction in it, that's easy. We basically just multiplying by the denominator. If you have more than one fraction in one equation, that's a little bit harder because you would have to find the least common denominator and then multiply by that number. But in this case, one fraction, so least common denominator is 5 for this first equation, so we multiply through by 5. 5 times 4 is 20x, then 5 times 3 over 5y. That's what's called clearing the fractions. The 5 on top, 5 in the bottom cancel out, and I will be just left with 3y. And then 5 times -15 is -75. Okay, so we cleared the fraction, the first equation, no more fraction, and we're going to have to do the same thing with the second one. Again, there's only one fraction, so we know exactly by what to multiply by the least common denominator, which is 5. And distributing through, we get 2x times 5, which is 10x. And then 5 times -3 over 5y. The 5 on top, 5 on the bottom cancel out, and we left with -3y. And then 5 times -3, which is -15. So I cleared the fractions. Now I can choose either one of the methods to solve a system of linear equations. And in this case, because they are nicely lined up, and especially I got a +3y and a -3y, I'm going to choose elimination. And I'm just adding down. So 20x plus 10x gives me 30x. And then 3y minus 3y cancels out to be 0. And -75 minus 15 equals -90. Solving for x, so divide on both sides by 30. And I'm left with x equals negative. The zeros cancel out, so 9 divided by 3 is -3. Okay, I found my x value, and I am supposed to go back to one of my original equations, but I don't like fractions, so I'm going to choose one of the two equations that I have already cleared the fractions. I'm going to choose the second one because it just has smaller numbers, and I'm going to plug in my x value. So I got 10 times -3 minus 3y, which is equal to -15. 10 times -3, so -30 minus 3y, which is equal to -15. Adding 30 to both sides, and I'm left with -3y is equal to +15. Dividing by -3 on both sides, y is equal to -5. So I basically got an x value and a y value, which means this system of equations is crossing at the point -3, -5.
Okay, number 16, factor the polynomial completely. So when we factor a polynomial, we want to always first check and see if we have a greatest common factor or a GCF that we can factor out. So we have 15x to the 8th, 27x to the 5th, and 9x squared. So what's the greatest common factor between 15, 27, and 9? 3 is the greatest common factor between those three coefficients. Now let's look at the variables, the x. So what's the greatest number of x's all three have in common? It'll be x squared. You're getting the GCF. You want to make sure they all have the same variable, and if it's a part of your GCF, and if they do, you want to take the smallest exponent. So we're going to factor out the GCF, 3x squared, and we're going to write what's left over in parentheses, and you're basically dividing everything by that GCF. So 15x to the 8th divided by 3x squared would be 5x to the 6th. 27x to the 5th divided by 3x squared would be 9x to the 3rd. And then 9x squared divided by 3x squared would just be 3. So this is our final answer here. All right, let's keep going. 17, factor by grouping. So we factor by grouping when we have 4 terms, which we have here. So we're going to start by grouping the first 2 terms, and then we're going to group the last 2 terms. Okay, so within the first group, factor out the GCF. So between 6x squared and negative 10x, the greatest common factor would be 2x. So we factor that out. We would have 3x minus 5. Now, factoring by grouping, we want to do the same thing, take out the GCF here, but our goal is to get another 3x minus 5. So keep that in mind. That can help you figure out what to factor out. So I need to get a positive 3x in parentheses. I'm going to factor out not just a 3, but a negative 3. So that when I factor it out, I'll get that positive 3x that I need and that minus 5 that I need. So now that we have factored out the GCF from each pair, now we're going to write what's in common between both of these, which would be 3x minus 5, and then just write what's left over on the outside, 2x minus 3. So we basically factored out 3x minus 5 and wrote it down, and when we factored it out, we were left with just 2x minus 3. So this is our final answer. We factor by grouping. And remember, you can always double check your factoring by multiplying your factors back together, and you should get the original problem that we started with. Okay, so number 18, factor the trinomial. So first we want to always check for a GCF. There is not a GCF here to factor out. So next we're going to look at how many terms. It's a trinomial, so there's 3 terms. So we need to set this up. Our leading coefficient is a 1, which is great because it makes it a little easier to factor. So we're going to start with 2 sets of parentheses, and they're going to start with an x for each of them because x times x will give us that x squared that we need. Now, this is our standard form. So if c is negative, so negative c means we're going to have different signs in our factors. So basically we want to have a positive and negative. Now we need to figure out the 2 numbers that multiply to give us negative 42 and add to give us 1. So if we think of 42, if we think of factors or 2 numbers that multiply to give us 42, if I think of 7 times 6, 7 times 6 is 42. Now I need to add the 2 numbers together to get 1, and they need to multiply together to get negative 42. And we already have here that one of them needs to be a negative number. So when C is negative, you have different signs. And then if B is positive, which it is in this case, the larger factor takes the positive sign. So it'll be positive 7 and negative 6. And that's because 7 times negative 6 equals negative 42, which is what we needed to happen. And then 7 plus negative 6 gives me that 1 that I need, which is the 1 here, which is B. So our final answer is x plus 7 times x minus 6. All right. And then just to finish this up, so if C was positive, you would have the same signs. And then depending on the B, so if C is positive and B is positive, you would have plus plus. If C is positive and B is negative, then you would have minus minus. So those are helpful tricks to help you set up your factors. Okay, number 19, factor the trinomial. So here the leading coefficient is not a 1. Before I get started, check for a GCF, and we do not have a GCF here. So leading coefficient is not a 1. So we're going to have to start by taking A times C. All right, so 7 times negative 10 is negative 70. Now this is the number that I'm going to use to find those 2 numbers that multiply to give me negative 70 and add to give me 9. So if I list some numbers that multiply to give me negative 70, let's see, I've got 7 times 10, I've got 5 times 14, 2 times 35, a lot of combinations here. It's negative, so I need to have one of these to be negative, and I want to add them together to get 9. Like I said before, C is negative, so they're going to be different signs, and then the B is positive, so the larger number gets the positive sign. So I'm going to set it up like this. I'm going to use grouping to factor this, so I'm going to rewrite 9x. So I'm going to write 9x using my negative 5 and 14. So it doesn't really matter how we set up. I'm going to write 14x minus 5x. That equals 9x. So all I did was rewrite 9x using 14 and the negative 5. Okay, so now I'm going to bring down everything else. 7x squared and the minus 10. So now I'm going to factor by grouping. So I'm going to start by grouping the first pair and then the second pair. So the GCF of the first pair would be 7x. And then when I factor that out, I'm going to be left with x plus 2. Now, I'm factoring by grouping, so I need to get another x plus 2. So the GCF between negative 5x and negative 10 is going to be negative 5, so I can get another x plus 2. Because negative 5 times x is negative 5x, and negative 5 times 2 is negative 10. And then now I'm going to write the x plus 2, and then I have 7x minus 5, and that's my final answer factored out. So there's a ton of factoring methods, and depending on which ones you prefer, we're going to show you another factoring method that you could use, and whichever one you use is completely up to you. This one is the AC method, trial and error, AC, there's so many names, but if you like to factor by grouping, this is a good method to use. But here's another method.
Let me go back one slide. I'm going to show you guys another method to use. So if you have a trinomial with a coefficient of 1, you're going to follow a few steps. Like in the previous problem, you write your empty sets of parentheses, then you are going to square root this first term, which gives you an x and an x. Then you are going to bring down your first sign, which is a plus, multiply the two signs together, which gives you the second sign. So positive times negative is a negative. And then you don't have to deal with the sign issue anymore, and you're basically just looking at the plain 42 without any signs and look for the factors. When you have different signs, the factors must subtract. If you have same signs, the factors must add to give you the middle number, which is 1. And the factors will be 7 and 6. To not have any issues with the signs, always put the larger one of the two factors first and the smaller one second, and it will work out 100%. Always with your signs. And now going to the next problem and also using this method, I'm just going to copy it down real quick. If you wish to use the Columbium method, the first step would be multiply the first number by itself and the last number by the first. Rewrite the problem. So we have 7 times 7, which is 49x squared plus 9x, leave the middle term alone, and then 10 times 7 is negative 70. So now, like in the previous problem, when you had a coefficient of 1, you're going to square root this first term, which is 7x, then bring down your first sign, multiply the two signs together, positive times negative is negative, and find the factors of this last number, which is 70, different signs again, so the factors must subtract to give you the middle number, 9, and in this case, you have 14 and 5. 14 times 5 is 70, and 14 minus 5 is 9. Always write the larger of the two factors first and the smaller second, and you have no issues with your signs. Now remember how we multiplied in the beginning by 7? We have to divide by the 7. And as you can see, only one of the two factors is divisible by 7, which would be the left side. I'm just going to put a 1 here because nothing changes with a 1. And then rewriting the 7 divided by 7 is 1x, and 14 divided by 7 is 2, and this stays the same, and that will be my answer. So these are two different methods, and there are plenty of more factoring methods out there. Just try to find one that 100% works for you, and stick with it, and you're safe to go with factoring. And it's really important to learn factoring because not only in this class but every other math and science class you will need and see factoring. So you need to have a method that really works for you.
So number 20, factor completely. So always look for a GCF first. We do not have a GCF between 4y squared and negative 9. So now we're going to look at how many terms we have. We have 2 terms, okay? So we either have perfect squares or perfect cubes. If we don't have one of those, then we're done. We can't factor it. So we have perfect squares, and it's the difference. We're going to use a squared minus b squared equals a plus b times a minus b. So if we take the square root of each term, that will give us the base for each term in a squared minus b squared form. So the square root of 4y squared is 2y. So that's my a, because 2y squared is 4y squared. And the square root of 9 is 3. So that's 3 squared, which equals 9. So now I can see very clearly that 2y is my A and 3 is my B. So to factor this out, I would say 2y plus 3 times 2y minus 3. And I am done factoring. So remember, you do want to know your factor patterns, so difference of squares, sum and difference of cubes. You need to have those memorized. It'll be much easier to factor if you have those memorized. And then factoring trinomials. So happy studying. Don't forget you've got the Math Depot for great resources. Utilize those videos. There's tons of information out there. We want you guys to do your best. All right? So y'all have a great day and a great week.